Hi friends, welcome everyone to Smart Engineering Academy. Myself Amit. Well, I am starting a new topic, that is structural analysis. Okay, complete lecture series on the structural analysis will be. So this series will be taken in the same manner as I am taking geotechnical engineering lecture series. That is, first I am going topic wise. See, there are like 11 topics here. I am going topic wise. Second thing, from every topic, first what I am doing, I am going to build up the concept. Second, the list of formulas which are important with respect to the topic. Third thing, graphs and charts. The important graphs and charts will be given. Finally, the important MCQs with respect to that topic will be solved. The MCQs from Indian Engineering Service, some gate questions, and some of the KPSC examination questions, KEA examination questions, KPTCL examination questions, and some questions with respect to other state examinations like assistant engineer, assistant executive engineer. All types of MCQs will be discussed and analyzed in a detailed manner. So let me come into the names of the chapter. The first chapter is static indeterminacy and kinematic indeterminacy. These two topics are very important. There will be minimum 2 to 3 questions in all the examination. When coming into the KPSC examination, irrigation engineering examination in 2017, there was like 2 questions from this topic, from static indeterminacy. As I see in the KPCL examination, there were like 3 questions from this topic. Normally in municipal board questions which was conducted on 2017, there were like 2 questions. This is very important and very easy topics as compared to and very basic topics of this structural analysis. One more thing I would like to add here is, before learning structural analysis, you must be thorough with the concepts and basic concepts which are involved in strength of material. Without knowing the basics, it is very important because it is a part 2 and the part 1 is strength of material. So in my Smart Engineering Academy YouTube channel, I had made one basics of strength of materials, that is how to draw shear force and bending moment. In that I had explained all the basic things with respect to what is shear force, what is bending moment, and what is determinate structures, what is indeterminate structures. You can go through those videos before coming here because that is very important. And trusses, important topic. Basics methods of structural analysis, important topic. Energy principles, coming into energy principles in public work department examination which was conducted in 2019, there were like 3 to 4 questions from energy principles. Moment distribution method, take it from me star into 5. You have to read this topic and there will be minimum one question. Okay, minimum of 1 question in all the examination. And slope deflection method, okay. And plastic theory, the basics of plastic theory is very important. Influence line, minimum 1 question will be there and important. Arches and cables, it is very small topic, very important topic as far as concerned, but if you want to learn arches and cables, you should be thorough with shear force and bending moment. Without this, it is impossible. Then coming into matrix method, it is not that important, but in future examination the question may arise from matrix method. So I'll take the lecture series from every individual topic. So these are the hints and this is the overview of the course which I am going to start. So let us go. Let me take the first topic, that is static indeterminacy. Let's go one by with the concept first and the basics first. First of all, what is structures? A structure refers to a system of connected parts used to support a load. So what do you mean by connected parts? A system of connected parts. The system of connected parts, when coming into the construction, the base consists of footing. Footing gets connected to a column. Is it right? So then the column is connected to a beam. Upon the beam, it contains slab. Okay, so the load which is coming from the slab, when coming into the part of the load coming from the slab, gets transferred to the beam. From beam the load gets transferred to the column, from the column the load gets transferred to the footing, finally into the soil. That is the reason all the structural frame parts are interconnected, so they are calling the structure refers to a connected parts. This is how the parts are connected. Next, when an elastic body is subjected to a system of loads, deformation takes place and the resistance is set up against the deformation, then the elastic body is called a structure. So they have given a simply supported beam here, and when the load is applied on this simply supported beam, you can see the structure is getting deflected like this. Because of the deflection of the structure, there will be a deformation. Because of the deflection of the structure, there will be a resistance which is get developed up the supports, and there will be a horizontal resistance, but in this rolled support there won't be any horizontal structure. Finally, because of the resistance of because of the deflection of the structure, there is a resistance that is offered to maintain the structure. So in any elastic body, if I take simply supported beam, of course it gets deflected like this, so this is called as deflection, and this deflection is resistance is given by the supports to hold the structure firmly in a position. So that is what about the structure, a basic scenario and the basic definition of the structure. Let me move into the next concepts. Then you need to know the basic things with respect to the type of supports and the notation of the supports and the amount of reactions required. Let me take one blank slide and I will explain you one by one. This was also explained in my strength of material topic, that is shear force and bending moment lecture series, but no issues, I will explain it once again here. Yeah, first of all, I'll take a structure which is, let it be hinged structure. Okay, this is hinged. In case of hinged structure, the number of reaction developed is 2. That is, when the structure is deflecting like this, the 2 reaction that is going to resistance, one is vertical reaction, let me take it as V1, and other one is horizontal reaction. These are the 2 resistance that will be developed upon the support, so the reaction will be 2. Then in the same way, if I take roller support, okay, if this is the roller support, okay, of course deformation takes like this, but only one reaction is going to develop. The horizontal reaction is not developed. That is because this roller support is free to move in the horizontal direction, but in the vertical direction it is not free to move. It will be resistance by 1, that is V1, and in case of horizontal, since the wheels rollers are given, it is free to move the horizontal directions. Normally these types of roller support will be given in the bridges. Because of the expansion and the contraction during summer and winter, there will be there should be some movements, lateral movements will be there in the bridges. That is the reason in those cases it has to be given. And here the number of reaction, the only thing you need to remember here is the number of reaction which is developed in the roller support is 1. In case of hinged support, it is 2. Then coming to the third one, that is fixed support. Fixed support, the number of reaction which is developed is 3. That is, one is vertical reaction, second one is horizontal reaction, third one is rotation, which is called as also moment. But these 2 things, hinged and roller supports, are not supposed to carry any moments. It will not carry moment at all. But only fixed support will carry moment, and it will be 3. It is not the resistance will be given in the vertical, horizontal direction, as well as the support will be given through the rotation also. So the total number of reaction is 3. I'll come back to this chart, which is very important. Please remember this. Fixed support, the total number of reaction is 3. Pinned support is also called as hinged. I told you it is 2. In case of roller support, it will be only 1 because it is free to move in the horizontal direction. It will be used in the bridges due to expansion and contraction. Everything is explained. In case of free end, the total number of reaction developed is 0. vertical shear, you please remember this vertical shear release support. In this case, the total number of reaction is 2. Horizontal shear release supports, it will be 2. Please add up these two things. Then coming into the types of joints, please make a note of these things. I will just explain in the upcoming slides. I will explain you what is difference between pin joint and rigid joint, and what is the difference between plane frames and space frames, everything. Please make a note of this chart. I'll come again and explain you this chart again after explaining you what is pin jointed, plane, space, everything. Then you need to know the difference between statically determinate structure and statically indeterminate structure. Statically determinate structure is a structure that can be analyzed with the help of equation of static equilibrium alone. But in case of this structure whose reaction components or internal stresses cannot be established by an equation of static equilibrium equation. In here, only with respect to equilibrium equation we can analyze the equation, but here it is not so. So the detail of these two things is been explained in my Smart Engineering Academy lecture series, in Strength of Material lecture series. That is in one playlist there is how to draw shear force and bending moment. Every details, every basics I had explained there. Please see that video before entering into this topic. So the difference between these two things is explained in that lecture series. The link of that lecture series I'll give you in the below description list. Please follow that that link and make your doubts all clear. Yeah, the basic formulation of static indeterminacy of the frames. What is DS? DS is total static indeterminacy. DSE is external static indeterminacy. DSI is internal static indeterminacy. So what is the difference between these three things? I'll just draw one structure here. So the external DSE, the external static indeterminacy, depends upon the support conditions. It is completely dependent upon the support conditions. That is, the resistance which is offered in the supports is one thing, and the second thing is the external load which is applied upon the structure. Okay, that comes into account with respect to external static indeterminacy. When coming into the internal static indeterminacy, see, DSI, internal static indeterminacy, is completely dependent upon the geometry of the structure, because structure has certain geometry which has to be prevented against any type of movement. So the internal forces will be acting inside. So these are the external forces, and the internal forces will be acting inside the structure. It is completely based on the geometry of the structure. Structure's geometry is very important. Sometimes the column will be given rectangular, sometimes the column will be given circular, sometimes the column will be given square, circular. So these are called as geometry of the structure. Depending upon this geometry, the internal static indeterminacy is dependent upon the structure. In order to find the external static indeterminacy and internal static indeterminacy and total static indeterminacy, we have certain basic formulas that I am going to explain, and I am going to give those formulas in the upcoming slides. Based on the classification of skeletal structure, based on the type of joint, with respect to type of joint, there are two things. One is pin jointed frames and rigid jointed frames. With respect to the dimensions, there is plane frames is one thing, second one is space frames. Please make a note of this, space frame. I'll tell you the difference between all those things, which you need to remember to understand the topic very well. Pin jointed frames, members are connected by means of pin joints. Pin joints is nothing but trusses. These frames support the load by developing only axial force. Okay, only axial force. If the external loads acts on the joints and the members are straight. Let me draw one diagram like this. Okay, let it be hinged support and let it be roller support. So these are joints. Okay, 1 2 3 4 5 6 7. So the number of joints which is present here is 7, and what I am putting two lines here, these are members 1 2 3 4 5 6 7 8 9 10 11. Number of members is equal to 11. But the thing is, and the point you need to remember here is, in case of this pin jointed frames, the load is applied only on the joints, and when the member is straight in these things, only axial force is generated. In this first case, only axial force is generated, but shear force is not present and bending moment is also not present. That is because the load in this case is applied only upon the joints, which is also called as trusses. Okay, pin jointed frames is also called as trusses, in which the loads are applied only upon the joints, then the loads are not applied upon the members. That is the reason it will be subjected only to the axial force, and it will not be subjected it will only develop the axial force, and it will not develop any shear force and bending moment. If any load is acted upon this member and it undergoes bending, and shear force will be generated, but this case is not happening here, and shear force is 0, bending moment is 0. The only force which is developed here will be axial force. Then coming into the rigid jointed frames, in this rigid jointed frame, axial force, shear force and bending moment, all the things are generated. Let me draw one frame here, let it be fixed. If you apply any load here, it gets deformed like this. That is the reason axial force is also developed, shear force is also developed, and bending moment is also developed. These frames resist external forces by developing bending moment, shear force and axial force and twisting moment. Okay, pin jointed frames is nothing but trusses, in which the load is applied only upon the joints and only axial force is developed. But in case of rigid jointed frames, axial force, shear force and bending moment is generated, which is nothing but frames. So that is the two difference between pin jointed frames and rigid jointed frames that you need to remember. Then second thing, based on the dimensions, plane frames and space frames, I'll just tell you what is the difference between these two things. Let me rub this area. So in case of plane frames, all the members of the plane frame as well as external loads assumed to be in one plane. But in case of space frame, what happens? All the members do not lie in one plane. Okay, do not lie in one plane. But in this case, all the loads will lie in one plane. Here it will not lie in one plane. In simple, we can say plane frame is called as 2D structure, and in the space frame it is called as 3D structure. So assuming the number of equilibrium equations and the reactions will be different in these two cases, that will be explained in the future. So that's all for this part. The remaining part will be continued in the next part. Okay, any queries, please do comment me in the comment section. Thank you, and I'll meet you again.